Okay, the goal of this video is not necessarily to teach you anything new right now or to show you examples of something. We're going to do those together in class just because this can get a little bit tricky. But we're going to define some important vocabulary words, some you've probably heard before. So first one would be infinite. Heard this before, but basically just know that a series is infinite or a sequence is infinite if it is unending or without bound, meaning it's going to just keep going forever. It's the opposite of finite, which we talked about in the last video. Finite has an end. So in sequences, a finite sequence just has a certain number of terms, whereas infinite will go on and on forever. And when we're talking about finding a series, we need to know if it's just going to be a finite series, meaning we're going to just find the sum of a certain number of terms, or if it's going to be an infinite series where maybe we can try to find the sum in certain situations. So when a series is infinite, for us to be able to find a series, a sum of all of the terms, it must be also convergent. So a convergent series, so make sure we know we're talking about a convergent series, means that it's approaching a definite limit as more of its terms are added together. So as we're adding the terms together, it starts to become, the sum starts to become the same amount every time. And so this is only going to happen, and we'll talk about that on the next slide, is when the ratio that you're multiplying by is has an absolute value between 0 and 1. So basically each term is getting smaller than the last, and so it's decreasing. So if a geometric term is if a geometric series or sequence is decreasing, then as you add those numbers together, you're adding smaller and smaller numbers. And so it's said to be convergent because we can find a value that it's going to begin to approach, which we call a limit. So a limit we've talked about, but just thought we'd add it to our notes, a long-run value that a sequence or function approaches. Lastly, I just want you to copy down, just so that we don't do it in class, the formula for finding the convergent infinite geometric series. So something that is infinite, geometric, and convergent, meaning it's going to come to start to become a certain number. And that means that each term is getting smaller and smaller. So that means that the common ratio should be less than 1. So the absolute value of r is less than 1. And basically, here's our formula here. The first term divided by 1 minus the ratio. And so it's a pretty simple formula. We'll talk a little bit more about it in class on how to use it, but I just thought that I'd want you to get this written down before you come to class the next time.